So what's the significance to a solution of a system of equations? Remember, a solution, you always write your solution as a point. For example, like 5, 2, right? Going all the way back to the beginning. When we graph two lines, most of the time those lines intersect. So that solution is the point of intersection. And you can find that solution by graphing, by using elimination, or by using substitution now, right? But we talked the other day. Sometimes two lines don't have a solution. In other words, they don't intersect. That happens when the two lines are parallel, right? So how do we know that that happens? Well, you know back from a previous unit that parallel lines have the same slope but different y-intercepts, right? So if you can look at the two equations and recognize, oh, these two have the same slope but different y-intercepts, you could say that there's no solution. They don't intersect, they're parallel. But if we're solving a system, how do we know that that happens without knowing the slope and the y-intercept? Well, let's look, okay? Here's 3 examples we're going to kind of fill in this table. If I were to solve this system algebraically, look what happens. I would use elimination, and I would multiply this equation by -1. Okay? I'm just going to recopy this top equation. And when I use elimination, I add these, I get x, these are going to cancel, is equal to 2, right? If x equals 2, I go back and I plug in to one of the equations, and I solve for y. So I have -y is equal to -1, therefore y is equal to 1, and my solution is 2, 1. If I were to graph these two if I were to graph these two lines, right? So my solution we came up with was 2, 1. I'm going to write that down, erase all this stuff, because I'm going to take a minute and graph these two lines, okay? I have to solve them for y. So subtract 2x, subtract 2x, I have -y, -2x plus 3, divide by -1, y is equal to 2x minus 3, right? So 2x minus 3 is going to look like this when I graph it. So my y-intercept is -3, my slope is 2 over 1. I have to go up 2 over 1, right? Now let me take a minute and solve this equation. So I have -y is equal to -x plus 1. Divide by -1, I have y is equal to x minus 1. So here's the -1, my y-intercept, my slope is 1, so I go up 1 over 1. And you can see that these are going to intersect at that point, 2, 1. So how many solutions do I have? I have one solution. When I solve the system using elimination, I got a point, x, y, right? When I graph, I can see that the two lines are going to intersect at one point. Well, let's look what happens with this second one, okay? If I solve this system using elimination again, I want to multiply the top equation by 2, and if I multiply the top equation by 2, I have 4x plus 2y is equal to 2, right? And if I add these two together, the x's will cancel, but what else happens to the y? They cancel as well. If everything cancels, I'm left with 0. But over on the right-hand side, I have 2 plus 2 is 4. So I have no variables to solve for. I can't solve for x, I can't solve for y, I get 0 equals 4. Is that true? Is 0 equal to 4? This is a false, what we call a false statement, okay? Well, let's look and see what happens when I were to graph these two, all right? So this top equation, I'm going to erase this stuff up here. If I were to graph this top equation, I subtract 2x from both sides, I have y is equal to -2x plus 1. So my y-intercept is 1, and my slope is -2. So I go down 2 and over 1, right? Up 2 over 1. So there's my first line, right? Now if I were to look at this second one, I'm going to add 4x to both sides. I'm going to jump down here. I have -2y is equal to 4x plus 2. get y by itself, I have to divide by -2, and I get y is -2x minus 1, right? So now my y-intercept is -1, my slope is -2. And what do you notice before I even graph? These two lines, this slope is -2, this slope is -2. They're parallel. They have the same slope, but different y-intercepts. Do you see that? So are these ever going to touch? Are they ever going to intersect? No, they're parallel, right? So because they're not going to intersect, we say that there are no solutions. Okay? So I want to note, like, what happened here? How did I know that there was no solution? You might want to jot this down. What happened when I solved all the variables cancel, and we were left with a false statement. In other words, 0 is not equal to 4, right? That's false. So when that happens, we say that there's no solution, okay? And there's no solution because the lines are parallel. All right? Let's look at the next example. Okay, now this one's set up nicely for me to use substitution. I'm going to take this, plug in for y, okay? So I have 2x plus 4, and then in parentheses, -1/2 x plus 2 equals 8. Distribute this 4. 2x minus 2x plus 8 equals 8, right? Well, what happens here? 2x minus 2x, that cancels out. That's 0. So all I have left is 8 equals 8. Same thing as before. When I solved all the variables canceled, but I have what's called a true statement, okay? 8 is equal to 8. Let's look and see what happens if I were to graph this. Y is equal to -1/2 x plus 2. My y-intercept is 2. My slope is -1/2. -1/2. -1/2, right? So that's what that line looks like. If I were to take this top equation and solve for y, I'd subtract 2x. I have 4y is equal to -2x plus 8. Divide everything by 4. I have y is equal to -1/2 x plus 2. Well, wait a minute. Look, the equations are exactly the same. So if I were to plot this line in blue, it would go right on top of the red one, right? So these aren't parallel. They're actually the same line. So every single point on this line here is a solution. And we know that we have an infinite number of points on a line. So we have an infinite number of solutions. Any point that's on this line is a solution. We have an infinite number of solutions because they are the same line. So when we solve, going back over here, when we solve, all the variables cancel, but we have a true statement. Then we say that we have an infinite number of solutions, okay? So if all the variables cancel and the statement's true, we have infinite number of solutions. If all the variables cancel and the statement is false, we have no solution. All right, so you don't have to graph these to figure it out, okay? So there's a bunch of practice problems on the worksheet down below, okay? Take a few minutes, try those practice problems, okay? Check answers with the teacher or with the sub, and if you have any questions, make sure you hold on to them for tomorrow, okay? Thanks, and have a great day.